Space is full of dangers, and perhaps one of the most terrifying possibilities imaginable is the sudden creation of a black hole capable of consuming Earth itself. The idea sounds more like the plot of a science fiction movie than reality, a growing void appearing somewhere beneath our feet, slowly devouring everything in its path until human civilization, our planet, and eventually every trace of humanity vanish forever. Yet in 2008, CERN activated a machine that scientists admitted had a non-zero chance of creating microscopic black holes here on Earth. Thankfully, we are all still here. The world was not swallowed by an artificial singularity. But the unsettling part is that CERN's own scientific discussion still acknowledge that the Large Hadron Collider could theoretically create tiny black holes under certain conditions. That naturally raises an uncomfortable question. Have we simply been lucky so far? And what risks are we taking as science continues pushing deeper into the unknown? The Large Hadron Collider, better known as the LHC, is one of the most advanced and powerful scientific machines ever constructed. Buried underground near Geneva, it consists of a 27-kilometer circular tunnel filled with thousands of superconducting magnets. Inside this enormous ring, beams of protons are accelerated to 99.99999% the speed of light before colliding head-on billions of times every second. These collisions recreate conditions similar to those that existed fractions of a second after the Big Bang. By smashing particles together with unimaginable precision, scientists can briefly produce exotic particles that normally do not exist in nature. These particles survive for only tiny fractions of a second before decaying, but detectors surrounding the collision points record the debris, allowing researchers to study the fundamental structure of reality itself. The LHC has already changed our understanding of the universe. It led to the discovery of the Higgs boson, the particle associated with why matter has mass. But CERN's ambitions go even further. Scientists hope to uncover the nature of dark matter and dark energy, understand why the universe contains more matter than antimatter, and possibly discover entirely new laws of physics. However, when the possibility of black hole creation became public knowledge, fear spread quickly across the world. Some people trusted the scientists completely, arguing that such experiments would never be performed if there were real danger. Others reacted with panic. Lawsuits were filed attempting to stop CERN from turning the collider on, while conspiracy theories exploded online. Some even claimed the LHC was designed to open a portal to hell. That particular idea was nonsense, but the fear surrounding black holes was harder to dismiss because, according to modern physics, microscopic black holes are at least theoretically possible. In nature, black holes are usually formed when massive stars collapse after supernova explosions. Gravity becomes so overwhelming that matter is compressed beyond all known physical limits, creating a singularity surrounded by an event horizon from which nothing, not even light, can escape. These black holes are enormous, often many times more massive than our sun. But interestingly, physics does not say black holes must be huge. In theory, a black hole of any size could exist if enough energy were compressed into a sufficiently tiny space. That is exactly why the LHC sparked concern. Particle collisions involve enormous amounts of energy concentrated into incredibly small regions. At first glance, the risk appears extremely low. Scientific calculations suggest that creating a stable black hole would require energy approaching the Planck energy, a level far beyond anything the LHC can achieve. In fact, the required energy is trillions upon trillions of times greater than what CERN currently produces. Yet there is a twist. Some theories, especially string theory, propose that reality may contain hidden extra dimensions beyond the 3 dimensions of space and one of time we experience every day. If these extra dimensions exist, gravity could behave differently at microscopic scales, lowering the energy threshold needed to create black holes. Under those conditions, the LHC might actually be capable of producing tiny artificial black holes for fractions of a second. This possibility sounds terrifying at first, but according to most physicists, even if such black holes formed, they would almost instantly disappear due to a phenomenon proposed by Stephen Hawking known as Hawking radiation. Hawking suggested that black holes slowly lose energy and evaporate over time because of quantum effects near the event horizon. Large black holes would take unimaginable periods of time to disappear, but microscopic ones would evaporate almost instantly in tiny bursts of energy. Even in the absolute worst-case scenario, the energy released would be microscopic, roughly comparable to the kinetic energy of a tiny grain of sand moving slowly through the air. Detecting such an event would excite scientists enormously, but it would pose virtually no threat to Earth. Still, some people ask an even darker question. What if Hawking radiation is wrong? What if microscopic black holes could survive and begin feeding on matter? Surprisingly, even then, the danger remains extremely small. Contrary to popular portrayals in movies, black holes are not giant cosmic vacuum cleaners sucking everything toward them automatically. A microscopic black hole would have incredibly weak gravity because its mass would be tiny. If it carried electric charge, electromagnetic forces would prevent it from easily absorbing matter. It would likely behave more like an unusual subatomic particle than a planet-devouring monster. Even without charge, the black hole would probably pass straight through Earth with little interaction. At the microscopic scale, atoms are mostly empty space. The odds of the black hole actually colliding with enough particles to grow significantly are extraordinarily small. It could travel through the entire planet and emerge out the other side almost harmlessly. There is also one final and extremely important argument against the fear of CERN destroying the world. Nature has already been performing similar experiments for billions of years. Earth is constantly bombarded by cosmic rays, high-energy particles traveling through space at enormous speeds. Some of these naturally occurring collisions are as powerful, or even more powerful, than those created inside the LHC. If microscopic black holes capable of consuming planets could be formed this way, Earth, the Moon, and countless other celestial bodies would likely have been destroyed long ago. So while the image of CERN accidentally creating a black hole sounds horrifying, reality is much less dramatic. For Earth to actually be destroyed, multiple highly speculative conditions would all need to be true simultaneously. Extra dimensions would need to exist, Hawking radiation would need to fail completely, the black hole would need no charge, and it would somehow need to absorb matter efficiently enough to grow. In other words, the probability is astronomically small. Yet despite all the reassuring science, the idea still captures the imagination because it touches on something deeply human: fear of the unknown. Humanity has built a machine powerful enough to recreate conditions from the birth of the universe itself. And whenever science pushes beyond the boundaries of what we understand, there will always be one chilling thought hiding in the darkness. What if, one day, we accidentally create something we cannot control?
Thanks so much for watching my video. I really appreciate you taking the time to be here. If you enjoyed it, don't forget to leave a like and consider subscribing. It really helps the channel grow and keeps me motivated to create more content like this. Also, if you want to be notified right away whenever I upload a new video, make sure to turn on the notification bell so you don't miss anything. Thanks again for your support, and I'll see you in the next video.